Sometimes people are happy, sometimes people are angry, and sometimes people don't care either way. For people working within a business, it gets kind of exhausting trying to figure out how people feel at scale, even though it's an important metric for understanding how well your business is performing with its customers. Well, close that file and stop reading customer reviews of your pop-up boba tea stand, because AI is here once again to save the day, making our lives easier and definitely not coming to exterminate us. Yet. But how will AI do this? I hear you enthusiastically scream at your screen. Well, for this we're going to use ML.net. And for understanding the mood conveyed within written text, we use a specific machine learning practice called sentiment analysis. Now, I'll get more into sentiment analysis and provide an overview of it shortly, but in order to get the most out of this video, I recommend that you have a basic understanding of machine learning, you have a knowledge or an awareness of ML.net, you know it exists. But don't fear, if you don't have that knowledge yet, you're coming in completely fresh. My last video was an introduction to machine learning using ML.net with the example use case of item classification. So if you're new to this, make sure you give that video a watch. And before we go down the AI rabbit hole, don't forget to like and subscribe to the channel for more content like this, .NET, software development, all that good stuff. So let's talk about sentiment analysis. Sentiment analysis is the process of using natural language processing and machine learning techniques to understand the emotional tone or sentiment expressed in a piece of written text. This could be a customer review, comments on a website, or social media post. The goal with sentiment analysis is to understand if the sentiment is negative, positive, or neutral. There's loads of different uses for sentiment analysis, but usually it's for things like customer service and market research. But essentially, you want to understand how people are reacting to your products and services, or to a particular subject. So because this is a machine learning process, we need an initial data set, and in order to create that initial data set, we label some pre-processed data. So during this process, we can assign negative, positive, or neutral values to items in this pre-processed data set. This gives us a basis that we can train a model on and therefore predict the sentiment of future incoming data. So for example, we could have a database of words. One of the words might be the word rubbish, and I could label that as negative, and I could have another word which is happy, and I could label that as positive. So for the example use case I'm going to demonstrate today in ML.net, I'm going to analyze some examples of website comments to analyze and identify positive, neutral, or negative feedback. I'm going to use an example that's actually on the Microsoft Learn website because they provide a really good data set as a starting point. But I'm going to try and keep it nice and basic and give you a little more of an insight and an explanation into what's happening during the example. So as usual, we're looking to make a console application for this use case because I just want to be able to input data and see an immediate response in a very simple application. So I'm going to go over to create a new project in Visual Studio. I'm going to select console app, and then I'm going to call this website comment predictor. Go ahead and create that. We're going to use .NET 8, and then I'm going to get rid of the template content. So the first thing we need is to have a place where we can store our data set. So I'm going to create a data folder inside this project. So I'm going to go over to the project and say add new folder. We're going to call that data. Then we're going to need to have a NuGet package installed, in this case the Microsoft.ml NuGet package, which will allow us to create our ML context, which you'll be familiar with if you saw the previous video, and then we can use that for the prediction and the training. So head over to Man NuGet Package Manager, manage NuGet packages for this solution, set it to nuget.org, and then search for Microsoft.ml, install that on the project, accept those dependencies and apply. Then we're going to download our example zip file for the dataset that we want to use as a basis for training on. So I'm going to head over to the Learn article that we're basing this project on, which is this one here. And as you can see, there is a link to a zip file. So I'm going to download that, just save that, and then I can open that up. Let's move that over there. And then we're only really concerned with one file in here, and that is the Yelp labeled text file. If I open this up just as an example, you can see what we've actually got in the example training set. So you can see here, this is quite similar to the TSV file that I showed in the last video. We use that as a basis for item classification, but for sentiment analysis, it's kind of the same principle, but a little bit more basic. We've got the actual example data. So, wow, I love this place, which is obviously a positive sentiment. And then we've got that set to 1, which would be positive. And then the opposite of that is crust is not good. Interesting example. And that is set to 0. So we just keep going down and down with this. And this is our basis for ingesting example data and training the new model. So I'm going to copy that, and then I'm going to save it in my project. So I'm going to add it to the data folder, and then we should see it present in the Solution Explorer. So now we've got it in our project. A really important thing we need to do is go to the properties of this file and set it to copy if newer. And again, I think this is because if you were to update the data, then you're making sure that you've always got the latest information, the most updated version. So there's a couple of using statements that we need to add to this. So I'm going to add using Microsoft.ml. We also need the data operations catalog, and we need that to be static, and that's part of Microsoft.ml. So I'm going to say using static Microsoft.ml.data operations catalog. Then we need to tell ml.net where the data is that we need to ingest. So this is our Yelp labeled text file. So I'm going to create a string property. I'm going to call it Yelp data path. I need to set that to the data folder in this project. So that would be in environment current directory. So that would be this projects directory, but it's not at the top level, it's in the data folder. So I actually need to do a path.combine. So that will allow me to build the path. So I can do that, pass in the current directory as the first part of the path, then it's the data folder, and then finally I can put in the actual name of the file, which is Yelp labeled.txt. So now the project knows where it needs to go when I tell it to read in the data from that text file. The next thing we need to do is create some classes. These classes will allow us to represent the data that we ingest from this file in memory. So I'm going to start by creating a new CS file. And that's going to be called sentiment data. So I don't need this to be internal. I'm going to set it to public. So there's two things I want to represent first. I want to represent the actual data being passed in. So the actual phrase that we're using from the data set. So if you remember the crust was not good example, that would be this. I'm going to set this as a string and make it nullable just in case something's been missed out in the data set. And I'll call this sentiment text. And then I want to represent the actual sentiment that was stored in the data set. So if you remember, that was a 0 or a 1. So we're going to use that as a Boolean variable that represents that number. So I can say public bool, and then I'm going to call it sentiment. So that will represent whether it's positive or negative in this example. Now that alone is not going to do much for us. It's just a class. So we're going to have to annotate this with some attributes, which allows ml.net to say, oh, okay, I can map these properties to the columns in the data set, in the text file. To do that, we're going to need to reference Microsoft.ml in this class, and then we can decorate this with a load column attribute, and this would be the first column, therefore load column 0. Again, very straightforward. Visual Studio already knows what I'm going to say. Load column 1 for the actual sentiment bool. I also want to say that I'm going to map this into a new column called label. If you've watched the previous video, you'll know that the label is essentially the representation of the result. So this represents the data coming in from the data set. I also want to represent the data coming out so that I can use that as part of my console application. So I'm going to create another class. We call it sentiment prediction. And this one's going to inherit from sentiment data. Now there's one thing I need to put in here which will map to the output, and that's going to be the prediction. So again, it's a bool to say whether it's positive or negative. So prediction, I can do, because I'm going to be updating this, I can say get or set. And I'm also going to have to map that to an output column, And again, if you've watched the previous video, you remember we used a name of predicted label. So this will be the result. There's some other information that I can also output, such as it's kind of like a confidence level. So it gives you a result and says how likely it thinks, how confident it is that it is that result. We're going to call that probability. So that will be a floating point number. So I'll make a float and call it probability. I think that's everything we need for our use case. So now we should be all set to actually load the data from that data set. So this is typically the first main stage in any of these ML.NET use cases. We have our data set up. Now we're going to ingest it and turn it into what's called an iData view. This is how ML.NET represents the data and is able to manipulate the data for pre-processing, which will be the next step after ingesting the data. So back in the program class, I'm going to create a new function. Bit of a correction on what I just said. The previous example held this data as an iData view. This actually uses a slightly different type called train test data. So it does use the iData view, but the result that we're going to use to actually manipulate the data is train test data. So I want to create a function which returns that type, and then I'm going to call that load data. And for this, we would accept an ML context. So if you're familiar with ML.NET, you'll know that ML context is pretty much at the root of most operations. Very similar to Entity Framework's DB context, it's where we access all the machine learning goodness. Then we are going to create our iData view. That's where I got a bit mixed up. I'm going to call it data view. And that will be equal to the raw data that we load in from the file. So we use our ML context that we passed in to go .data and then load from text file, which is of t, so it expects a type. We're going to be representing it using our sentiment data class that we've just created, and then it expects the path to the data and the options for the text loader. So the path is the string that we created, Yelp data path, and then I'm going to put in a property of hasHeader false. Now that is already set as false, so that's probably incorrect actually. I probably don't need to put that in, so I'll leave that as it is, and then I'll add a using statement for website comment predictor so that I can get the sentiment data class in here. And there we go. So we should have an iData view which represents the data we've just ingested from the text file. Then we create our train test data type, and that's going to be called split data view. And this is because the ML context will split the content into partly trained and partly testable data to build this pipeline. So ML context.data.train test split. And that function expects the data, which will be data view. And then you can specify which fraction of the data actually goes into the testing set. So because it splits it up into training data and test data, you can say, okay, take 0.1, which is the default of the data, and assign it to that test or test data. I'm going to say 0.2 just to give it an extra bit of data for testing. And then we just return that split data view so that we're returning a train test data type. So there's our load data function. Now we can't use that without an ML context, so we'll have to initiate or initialize an ML context on a generic level or at the top level so that we can use that throughout our project. So I'm going to define it here, ML context underscore ML context equals new ML context. Then we can specify that our train test data, which will be our split data view, so I'm using the same variable name as what we've got here, and that will be equal to load data passing in our ML context. So we've got our path to our file, we've got our ML context, and we've got our data split up between training and testing into the train test data type. Now we have enough to be able to create a model. Just as I did in the previous project, I'm going to create a build and train model function, and that's going to return a type of iTransformer. So I'll say iTransformer, build and train model. Visual Studio already knows that it's going to take in an ML context, but it also needs the split train set we've just created, but not the full type. It's just part of that type, which is actually a data view. I'll get into that shortly. So this is where we get into our pre-processing. Now, again, if you watched the previous video, you'll know that we first need to featureize our text. Featureization, as a very basic reminder, is a way of converting written text into numerical vectors. It makes it easier for machine learning algorithms to predict the difference between different values if they're in a numeric format. So by featureizing them, we're appending together this pre-processed model of numeric values that can be used as a basis for our prediction. The type of this is an estimator chain. It's kind of like a pipeline for the estimator. So I'm going to create it as a var and call it estimator. And to do the featureization, we use the ML context.transforms text namespace and then featureized text. So we have to specify an output column name for the featureized text. So we're going to call that features. We also have to specify an input column name. So for that, we can say that it's name of sentiment data.sentiment text. So here we're saying what type should be input as part of the featureization. And then we need to append to this estimator, and we're going to append a trainer which will have its own machine learning algorithm that is specified. So this is actually going to use a bit of classification as part of it. So even though we're doing sentiment, we are still using some item classification under the hood because we need to be able to classify if a piece of text is positive or negative. I know I mentioned neutral before, but actually we're not really going to touch too much on neutral, if at all. Positive and negative. And that's a binary value, isn't it? It's either positive or it's negative, so it's binary classification. Multi-class classification would be where something could be more than one thing, but in this case, it's either one thing or the other. So we're going to use a binary classifier for training purposes. To do this, I'll again access our ML context. Then I can go to binary classification, trainers, and then I'll select a specific algorithm within that set of trainers. For this, I'm going to select the SDCA logistic regression algorithm. I would say go with the algorithm that is specified in the documentation for your use case. For sentiment analysis, it's recommended to use this regression algorithm. So that's what I'm going to use. So it expects a label column name. So we're going to be using the column name label. And it also expects a features column name. So this is where we're going to be feeding in that featureized text. And so that's featured into the features column. So think of this as a column-based data set. We're just telling the training algorithm or the pipeline where the data is in terms of columns in that data set and then mapping to it. So features is the feature column name. So that's our pipeline or our estimator. Now we can engage with that estimator by calling the fit method. And this is essentially what trains that model. So we'll specify a variable called model, and that will be equal to estimator.fit, and we pass in our split train set, our data view. Then we can return model, which will build the model and then train it. That means then that I can call this in the top level and say I transform a model equals build and train model. It's going to expect the ML context. And then it needs that split train set, which is an iData view. We've got a type of train test data, which we can't pass in. We can pass in split data view dot train set. That is what we need to pass through. I think for this, you could probably get away with changing load data to type of iData view, because I don't think we're using anything else other than this train set inside that object. But for the purposes of reliability, I'm going to stick with what the documentation says, and I'm going to keep it as a train test data type. So this is the fun bit. This is where we actually get to predict using that model. So I'm going to create a new function for this. Actually, it's a method. It's just void. And I'm going to call it get prediction for review content. So this is something where we can pass an example line of text into it, and it will then do a prediction and return the results or print the results on the screen. So we'll need the ML context. We'll need our model, and then we'll obviously need the content that we're going to predict against. So to get things running with the model that we've created that's been trained, we need what's called a prediction engine. So there's a type in ML.NET called prediction engine. It is of type T source and T destination. So it takes a source and it has a destination to route the data or route the result into. If you remember from when we created our classes, we created two classes. One of those is the source, one of those is the destination. So the source is sentiment data and the destination is sentiment prediction. We're going to call it prediction engine. And to initialize this, we use, again, our ML context that we've passed in. That's got inside the model space, create prediction engine. And then we, again, have to specify the source and the destination. And then we pass in that model. So then in order to pass in the string that we're testing with, so it could be a line of text that said, my soup was cold, or there was a hair in my sandwich, then we need to create a type of sentiment data because that's the source. So sample statement equals new sentiment data, and I'll say that the sentiment text is equal to review content. It's equal to what we've passed in for this method. Okay, so now we're ready to get our result. So we can do this by calling the predict method on the prediction engine. So I'm going to say that our prediction result is equal to prediction engine.predict, and then we're going to predict on the sample statement that we've passed in. Now that's great, we've got our prediction, but I want to write that out to the console, and I want to write it out as a string which says whether it's positive or negative depending on whether the sentiment result was 0 or 1. So I can write this out to the console using a ternary operator, essentially an if-else. If it's 0, write the string negative, and if it's 1, write the string positive. So console.writeLine, I'll use some string interpolation, and we'll say the sentiment is, we'll say sentiment prediction predicted as, and this is where I can do my ternary operator. So the first thing I want to do is convert the 0 or the 1. So I'm going to do a convert to Boolean, because I think this comes in as a string, and I will be converting prediction result dot sentiment. Because convert to Boolean will return the Boolean result, then I can say if it's true, because it would return true if it was, then it will be positive, otherwise it is negative. But I think I also want to put in the confidence level, because the probability is really important. It gives us an idea as to how accurate the algorithm thinks this is. So I'll say probability, and then that will just be the prediction result dot probability. And now that we've written that, we can simply call get prediction for review content, and then we can pass in our ML context that we've created, the model that we've built and trained, and then whatever text it is that we want to predict. So we can say that my soup was not warm enough is what we're going to test against, and then we can actually run this console application and see what we get. I'll put a console.read line at the end, just so that it doesn't close, and we'll give this a run. So we've got an error here because I think I formatted this console.writeLine incorrectly. So actually, yes, this needs to be its own closing statement, and I just haven't encased this in parentheses, that's why. And then we get the result, sentiment predicted as negative, probability, and it seems to be pretty low on confidence. So this suggests to me that we will probably want to train negative on that phrase. So similar to my last video as well, I'm going to change this so that I can essentially keep passing in phrases and getting the result for them. So I'm going to create a Boolean called keep running, set that to true, and I'm going to say while keep running var input text is equal to console.readLine, so that'll be whatever the user's passed in. And then I can just call get prediction for review content, I can use ML context, I can use the model, and then I can use input text. And that will print it out to the screen. I'll also print out, get rid of that console.readline so that it doesn't stop. And I'll also print out a message. Please enter phrases to get sentiment. I'll get rid of this get prediction for review content up here. So essentially now I've changed it so that we're still doing the same setup. We end up with a built-in trained model, but then we're asking the user for input, and while keep running is true, which it always is in this case, we're going to be accepting input and then showing the sentiment for it. So I don't like this restaurant. Predicted as negative, and a much higher probability on that one. I loved the food. I'm actually getting back some negative responses where I'd expect positive. It's prediction result dot prediction that I need to be converting to a Boolean and checking the result of. So let me just test that again. So if I said highly, just zoom this in. Highly recommend. Yeah, predicted as positive. So there you go. I just put in the wrong value for the Boolean parsing. The food was great. Positive, the food was terrible. Negative. So there we go. We've got the basis of being able to pass in some text and get a sentiment result. So you can expand on this by saying that you can also pass in phrases and then train the model again every so often so that you start building up a better, more accurate model based on the inputs that you're receiving. There's loads of stuff you can build on from this, but I hope this was really useful. Don't forget to like and subscribe for more of this kind of content, and I'll catch you on the next one.